right, so we're Subteam 2, and this is our Week 4 update.
Alright, so for our mission statement, overall MQP mission statement, for our overall MQP mission statement, the project aims to improve a previously built CNC milling machine by implementing a robust cooling system, tool changer, noise reduction system, easy use interface, and safety mechanisms at low cost for WPI students and hobbyists. So our sub-team mission statement is to expand upon last year's by integrating more user-friendly software, adding more safety features, implementing dampening systems, and adding more features such as tool changes and spindle speed control.
Alright, and so here's our measurable goals slide.
So for vibration, we want to reduce the amplitude of static vibrations from the initial mill to the improved mill with a minimum of 25% amplitude reduction. And then we want to also provide a user guide with the optimal operation parameters for the included tooling with the machine that will have reduced chatter.
And then for software, we want to have software that supports the options chosen by other sub-teams. We want it to be free and open source, compatible with different computer OSs, and under $200 for the software and control system.
On the electronic side of things, we want obviously parts that are compatible with the overall software. We want normally closed limit switches and more identifiable wiring, so it's a little easier to track where cables are going.
For ease of manufacturing, we want it to use only basic hand tools, a drill press, bandsaw, 3D printer, soldering iron, and minimally outsourced parts.
And for affordability, we want our base model to cost roughly $1,500. So this just includes the basic axes and spindle, and then add-ons for additional costs for tool changers, a fourth axis, a hardware user interface, and embedded software controller.
For our safety goals, we want a e-stop switch on the enclosure door so that it's impossible to have the power on and the door open at the same time. We want some operational indicator LEDs somewhere on the machine so that you know if it's on or powered at any given time. We want the temperature sensors to be integrated inside the machine so that they can track the temperature of the enclosure. And also we want to incorporate some kind of locking tagout system so that only approved users can open the machine. So our sub-team goals for this past week we've completed some more literature review. We're on track with that. We've been choosing our components and methods and narrowed down our sensors that we want to use using the decision matrices, make sure that those are compatible with the needs of all the other teams. We've started some of the report outline that has to do with both the background section and the other two sections that we're working together on. We want to begin documenting OSHA requirements for CNC machines and standards that we have to meet. We've begun that. We're going to be compiling a list of those requirements very soon. We want to choose our CNC software and control system. We're almost done. We've been meeting and talking about that with everybody else in our group to make sure we're on the same page. Do you remember which one that was? If we knew?
Not quite yet.
Not quite yet. All right, that's okay. And we've talked to the professional, I guess, Peter, with regards to how we want to run our initial vibration experiment, with what components, and how we want to go about doing that.
So for our accomplishments, as Perrin said, we had a meeting with Peter Hefty, and a couple notes from the meeting is that the accelerometer we use should have a gyroscope as well, and an Arduino Uno might not have a high enough sampling rate. We need to define what enough data points per second we are looking to collect. And Peter also said we might be able to borrow something from the lab to look at the data and work with LabVIEW for analysis. And he recommended that we use accelerometers that will transmit analog signals. So if we choose an Adafruit sensor, we aren't stuck using an Arduino Uno to look at the data.
And then also we added elements to FMEA. So we talked about limit switches failing, having loose wire, the e-stop failing, billing while the door is open, which it currently does, and having our temperature sensor failing. Then we also revised our measurable goals as seen from the slide earlier. And here is the FMEA. So the more serious ones are billing machine being open while it's operating, which is very dangerous. And then, of course, the e-stop failing, because right now it's more of a control signal on a board rather than a hard cutoff for the power.
All right. So some of our goals for next week, we want to continue running that vibration experiment, continue drafting our report background and everything else in the report outline, finalize the software that we want to use with the CNC machine, and finalize the electrical components that we're using so that we're ready when we do our part ordering. So now we're on to our individual accomplishments. Let's go up first.
So this week I have spent 4 hours working individually so far, and then 7 hours in group meetings, including this meeting. And number of updates I forgot to fill in, but we are at 3 updates so far, and I will make a final update Friday night. What I've worked on this week is more research on accelerometers, both wired and Bluetooth, and I've worked more on experimental design for the vibrations experiment. I've also done background research on how to control vibrations, and as I mentioned, most of my time this week has been spent in group meetings so far and just having discussions.
All right, so for my accomplishments, roughly 6 hours individual with some working with code, and then 5 hours with working on the control matrix, and then a total of 6 group working hours, so roughly 4 with our sub-team and 2 with mostly our whole team. And then I forgot to put it up here, but it's going to be 4 updates after today. So with the code, one of the lab staff gave us, I modified it so I would compile and output the log info in CSV format so we can just directly upload that. And then I also worked on the software control matrix. So before I kind of had the software and control boards intermingled, but now I separated them. And I am also looking to a new software controller, since as of right now it looks like we're going to be using Gerbil HAL, and I wanted to offer another option for that.
All right. And
So this is our this is the software matrix. So as of right now, BCNC is the winner, but I haven't looked at the Universal G-Code Center yet. And then I modify these to show which hardware they're compatible. So obviously Mach 3 is still Mach 3, Linux CNC is Linux CNC, and BCNC is for Gerbil and Gerbil HAL. CNC.js is only for Gerbil HAL, and then Universal G-Code Center is for Gerbil and Gerbil HAL.
Right.
And then for the control boards, right now the control boards are, aside from the weight values that need to be discussed, these are finalized. So as of right now, it looks like Pico CNC with Gerbil HAL is going to be our control board chosen for our CNC machine. And then here I have a preliminary addition of both the software and hardware. So as of right now, it looks like BCNC and Pico CNC working together is the best option. So as of right now, that looks like what we're going with, but that is subject to change.
All right. Just some my accomplishments. That I should have removed the TBA. I've had 6 hours of group meetings, 4 hours of individual work, and updated 4 times. I've continued research into the safety latches at the CNC machine's door. We may end up going with a different design that, instead of cutting power when you open it, requires you to cut power before you open it with the door locks. I've compiled the list of new parts that weren't in previous last year's model that we want to use this next time, as well as working on the report introduction and the outline of the full report. Like everyone else, we've had a lot of group meetings this week, which is good to make sure everything's in working together. All right, and if you have any questions, just tell us in our group channel. Thank you very much.